There, it's working. I looked it up. This would happen in real life with olive oil and water. See, the difference is, so, I mean, in case you didn't read it, I guess, you've got 10 kilograms of olive oil and 10 kilograms of water, big old pots of water. You put them on a fire that's doing exactly the same thing, putting exactly the same amount of heat in, and after 5 minutes, the temperature in the olive oil was twice the temperature of the water. That's the way water and olive oil go. They each have a specific property that says how much heat you have to add in order to heat them up. Y'all have noticed how long it takes to get water to heat up, right? Mm-hmm. Especially to get it to boil. It takes a long time. It's about the bonds between the molecules, pretty much. You keep your mask on, please. I'm trying to, follow the rules.
I don't have one of those.
It's about, nobody can see me. It doesn't matter. You can just see my forehead.
That's the best part of your videos.
Excuse me, sir.
There.
That's the whole video.
I get distracted, honestly.
You think I watch it because
good.
I'm learning?
I'm glad y'all have jokes. So, what am I saying? That's called specific heat. How much heat you have to add to something before it'll heat up. Then technically specific heat is how many joules of heat you have to add to 1 kilogram of a substance in order to heat it up by 1 degree Celsius. Sometimes specific heat is measured in joules per gram times degree Celsius, or calories per gram times degree Celsius, because they're very similar. But
It's pretty whack.
it's fine. So hopefully this thing will keep recording, and I'll show you some stuff. Yeah, here we go. Okay. Make sure it's still recording. Oh, good. Well, we can do math with the specific heat, and I will show you. So, we've got this formula, Q equals mc delta T. Can you see it?
Barely.
It's right there.
Yeah.
Q is for heat. You have to be careful because there's heat and then there's specific heat. So Q is for just heat. That's how many joules of heat you put into the water before it'll heat up. Q equals mc delta T. M is the mass of whatever you're heating up, like the water. C is the specific heat, or the specific heat capacity, or the heat capacity. That's that specific property that says how much energy you have to add to it in joules before it'll heat up, depending on how much mass there is, and depending on how much you heat it up. Delta T is the change in temperature. Y'all remember this delta Greek letter means change in? So delta T means change in temperature, which you can make a little formula for that if you want to. T final minus T initial. Which, I mean, you can do that. You can say, okay, we started at 20 degrees and we ended at 100 degrees. So final minus initial is 100 minus 20. That makes 80. But really, like, if you start at 20 and go up to 100, you went up by 80. You don't have to subtract. I mean, but you can if you want to. So, let me do an example here. So it does give you a bunch of different formulas so that you don't have to do algebra, I think. But I like doing algebra, so I'm going to do algebra with this one instead of using this formula. If you wanted to find specific heat, you can just do Q divided by M times delta T. But I'm going to list out my stuff and do it the way that I like doing it, the way I usually do it. So the mass is this many kilograms. A 0.01575 kilogram piece of iron absorbs 1,086.75 joules of heat energy. It said heat. It did not say specific heat or heat capacity or specific heat capacity. So this is Q, and it's measured in joules, so you know it's Q. So that's how much heat it absorbed. That's how much heat it took to heat up the thing. And its temperature changes from 25 to 175. So it went up by 150. Delta T, 150 degrees Celsius. If it had gone from 175 to 25, it would have gone down 150, and delta T would be negative 150 because it changed by negative 150. It went down by 150. If it had done that, but it went up, so we say positive 150. And it says calculate specific heat capacity. So C equals blank. So I can do that. I can write down my formula. Q equals M times C times delta T. Q is this 1086.75 joules. M is that 0.01575 kilograms. Well, these are long numbers, but at least it's not scientific notation. C is what we're looking for, and delta T is 150 degrees Celsius. And then I got to multiply those, and oh boy, I already did this and I don't remember what it is, so oh, throw me in jail. Throw away the key. I don't. Here we go. Okay, now I take me out of math jail. I figured it out. It's 2.36, and I'll just say 2.36 and be done. So 2.36 C. That's this number times this number ends up 2.36. And I still got my 108.675 joules. So to get C by itself, I want to say equals C. It says C times that 2.36. So I'll divide by 2.36. So here we go. 108.675 divided by 2.36. I get 460. And like I said, specific heat can be in joules per gram times degree Celsius, joules per kilogram times degree Celsius, calories per gram times degree Celsius, calories per kilogram times degree Celsius, so a bunch of different things. We used kilograms and joules and degrees Celsius. So then this one is going to be joules per kilogram times degree Celsius. I'm not going to make you memorize the unit. I just want you to know that it can be different things. And in the answers that I've posted for this, some of those used grams, and because like this one says kilograms, the original question said 15.75 grams, so the decimal place was just moved 3 times over. That turns out to make the answer decimal place move 3 times over. So if you don't get the same thing as my answers, that's why. It's because of the decimal. Just move the decimal place over and then check it, and then it should work. Any questions about the specific heats? Okay. All right, please try out this specific heat here.